Hello, my name is Alex. Welcome to my demonstration of the multi-classification accuracy assessment tool that I have developed as a script tool in ArcGIS. In order to best demonstrate this tool, I should probably talk a little bit about the motivation behind it. I actually conducted a comparison between two classifications in a project that was done in the spring. And I found that the series of tools in the traditional accuracy assessment didn't really translate well to multiple classifications. If you're working with the same study region in the same extent, it would make sense to be able to use the same ground truth points for multiple classifications. However, the compute confusion matrix tool doesn't do a great job of handling more than one ground truth point, ground truth layer, accuracy assessment point layer. So I decided that basically this was cumbersome. It was too much work to do two, 3, 4 for those who are doing more than one classification. It makes sense that if you're trying to get to compare different classification methods, it would make sense to have a more streamlined workflow. And that's why I came up with a modified plan that would potentially reduce frustration in my case and also time spent sort of in the trenches. So my tool comes in after the creation of the accuracy assessment points. This particular project used a point-based stratified random approach to creating accuracy assessment points. However, that would be a choice that a user would make when evaluating the accuracy of their classifications. So ground truthing actually involves changing the values at each individual spot. In my case, I used aerial imagery in order to evaluate the actual ground cover that was being observed at each individual point, which counted up to 977 total points. As you can see, doing that multiple times is time consuming, so doing it once is better. This particular tool that I've developed takes a geodatabase of any number of classifications, whether it be raster or feature class, which is nice when, for example, in my case, when you have a pixel-based and an object-based classification being compared. Also, the nice thing about this particular tool is that it creates a worksheet for each matrix and puts them all in one spreadsheet, kind of going the extra step in this particular case compared to the traditional method. Also, I added functionality so that the points in which not all classifications matched, they would be exported to a new point feature class that contained all of the inaccuracy points, if you will. So we're going to go ahead and pull up the ground truth points. So this is how many ground truth points there are, and you can kind of generally see what's what here. The blue is water, red's developed, and so I will show you what my accuracy assessment toolbox contains my script, which when opened does look like this. I do already have these inputted in here to save time. So before I continue, I'll actually briefly run over so you can see that I do have some explanation as to what the tool does and what each parameter requires, which is really nice. If you need to, you can go back and pause and read those. I'm not going to read them right now due to time, but I am going to run the tool really quick so that we can see how it runs. It is pretty fast. I don't know if it's going to be as fast with this. If I need to, I'll pause, but you can see that the details include some printed information here, and I will talk about this 3-step process later when I look at it from a programming standpoint, but from a user perspective, you can see that the different steps are shown. So this first step is the get classification values at ground truth points. So in order to create the matrices, you have to first get the classification values at each ground truth point, and that's exactly what this first step does. It processes each classification and makes its own, makes a copy of the ground truth point class and adds a field for each classification. You can see that my 977 records have been found. You can see that step 2 is to compute the confusion matrices, or error matrices, they're sometimes called, and statistics. So I actually have it so that it's printing some crude values, so to speak, right here, which is nice to look at whenever you just want to see real quick what the accuracy is. This one is 88%, and this one is, well, that's a copy of, just to test to see whether or not it works with 3. And then 77% is the one for the pixel based. So you can see that step 3 is to generate the inaccuracy points, and it gives you the nice little information there. So I'm going to show you what the output actually looks like. This is the accuracy assessment copy of the ground truth values. But if you look at the attribute table, it actually does have a column for each classification that was in my classifications geodatabase. I have a copy of the object 1 just to demonstrate that it does work with more than 2. You can see the match field, which has yes and no values, depending on whether or not all of the values in the row match. To kind of close out of there and show you the inaccuracy point layer, you can see, if it shows up, there we go, okay. You can see I have it so that the places where there are inaccuracy, the points are actually X'd out. So these are the places where things don't match. If I zoom in right here, ooh, a little too much maybe, you can see the places where there are shadow is some inaccuracies due to the fact that the pixel base layer has shadow. Oh, actually, first I am going to show you the Excel spreadsheet because it was something that I was pretty proud of. So the red values are ones that I've actually added after the fact, just to show you. You would sum the rows and columns to get these values and then divide to get the overall accuracy. But the black is the part that was automatically created by my script tool, and these are the same base values because of the because it's a copy. The last sheet is the pixel based, so you can see that it's it has different values, and I will show you actually that this assessment is actually more accurate because it has a total of 977 points, whereas my classification had a total of 981 points because when I intersected, it created some extra points that shouldn't have been in there. Fun fact. So this, my accuracy assessment, multi-classification accuracy assessment tool actually works better than the method that I used for the other project. Alrighty, so now we will look at the script really quick. So I have some descriptions. It's all located in one Python script, and I have some, these divided up into your basic parts and steps, which is important for staying organized. I also would like to really briefly talk about the 2 coolest parts of it, which I appreciate a lot because it saved a lot of work for me. The first is the pandas_ml module, which I use the specific confusion matrix functions within that, and I was able to use this to calculate and display all of the statistics for my accuracy assessment, which was really nice because otherwise I would have had to do everything from scratch, and that I tried to do it from scratch and decided maybe there's something out there that I can use instead, and this was one of the things that I was able to use instead. This particular Python script tool does require the download of these two modules. So, you know, as much as I am enjoying the usefulness of these, I do recognize that that can be a bit annoying for some, or maybe those who are not as familiar with Python scripting. However, the other really nice module that I use, which could come in handy for many other applications, I imagine, which is the XLSX Writer module. That is the module that I use to write my Excel spreadsheet. And let's use here. Really handy, lots of functionality. I was only really able to scratch the surface with it. However, I really like that I was able to put everything in one spreadsheet. It reduces confusion and taking up of space and switching back and forth. I really appreciate that particular functionality of that module. I am really happy with this. I'm hopeful that I'll be able to use it in the future, and I welcome anyone who would like me to share it with them. Thank you.